So either you just all guessed right or not. Hey, the big thing is just get rid of your negatives. Either pull it out front or you can eliminate it. Cosine and secant are the only ones that you can just kind of... It is broken, isn't it? We should go steal one from the other class. All right. So cosine is the only one that the negative sign you can just get rid of. All the other ones you have to pull out front. So cosine and secant you could just get rid of. Remember, I could have quizzed you on this today. It'll probably happen tomorrow. It's printed out. It's printed out up there. I just decided today is not. I should just throw them out.
No, recycle.
Yeah, recycle. However it leaves the classroom, it just needs to leave the classroom. All right, so just be ready for that tomorrow. It's not bad. As long as you know your cosine goes with secant, secant goes with cosine, vice versa. Tangent is sine over cosine. Cotangent is cosine over sine. And know your three major Pythagorean triples. All right, but they all come from sine squared plus cosine squared equals 1. Divide everything by cosine, you get one of them. Divide everything by sine, you get the other one. Bree, why do you have a question already? No, I'm just kidding. What's up?
So you know the reciprocal identities and like, do we get what do we all need to know?
So basically you need to know all of this minus, so I'd basically give you the sheet, but to be semi-blank, you don't need to know these variations. All right, that is stuff that you just kind of develop as you're doing the problems. All right, but you should be able to list these completely. And you should be able to, say I blank there, and I put equals 1 over cosecant, you should be able to put sine over here. Same thing down here, if I blank out this sine over cosine, you should be able to go tan x equals sine over cosine. So it would be basically the same sheet with information missing that you have to plug in. This would all be blank. So you need to know all of these. And the odd evens. Okay. Questions from the homework? Mary.
Am I like combined two? They're kind of like the same.
Ooh, let's see.
38 and 40.
30 and 40?
Yeah, like 38 and dx.
Oh, 38 and 40.
Yeah.
Okay.
Sorry.
That's okay. No.
So like it says secant. Wow, I can't talk today.
Secant.
Secant of negative x.
Mm-hmm.
So I move the negative sign to the front.
It doesn't go to the front. For cosine and sine, cosine and secant, you just get rid of it.
Oh, so that's what 40.
Yeah, so then you have sine x minus sine x. And then 40 is probably the same thing. Cosine is, once again, cosine's that weird one where it just kind of, you can get rid of it.
Okay.
Since you can get rid of it for cosine, you can get rid of it for secant since they're just reciprocals of each other. Everything else, you have to pull it out front. So if you were going to make that mistake, you should probably pull it out front because it happens more often than it just going away. So if you're not sure, you might as well pull it in front, kind of like you did. All right, other questions?
Thank you.
Bree. All right, for 46, the first thing I would do is get rid of the negative signs. Since it's tangent, you pull it out front. Cosecant also gets pulled out front. That's a negative, negative. So in fact, those just disappear. Let me get rid of that real quick. So we're just going to have tangent, beta, cosecant, beta, cosine, beta. All right, now we're going to put it in terms of sine and cosine because I do have cosine here. So tangent becomes sine of beta over cosine of beta. Cosecant becomes 1 over sine beta. Well, just looking there, we have sine over sine, so that's going to cancel out. And finally, we're left with cosine of beta, which is really cosine beta over 1. Cosine over cosine, you get rid of it, and you're left with 1 over 1, which just equals 1. Emma.
I don't understand why the negative, like what happened.
So we went back to the odd even property.
Yeah, so negative 10 equals negative.
Yep, so negative, so if I have a negative inside, I can bring it out front.
Yeah,
And if I have cosecant, I also bring it out front.
no, that's what I did.
So we would have negative tangent times a negative cosecant, which becomes positive.
Okay.
A negative tangent times a negative cosecant. So I guess I could write that above. So what happens when you pull it out front is you'd have negative tangent beta times negative cosecant beta times cosine beta. And a negative times a negative becomes a positive. Other questions? Mary.
Sorry, can you tell me how you get sine cosine for number 27?
How we get sine and cosine? So you have tangent, right? So we have tangent equals negative 3. So then we just go to our identity sheet, our Pythagorean triples, and look for one that has tangent in it. Well, we have 1 plus tangent equals secant squared. So we're just going to do secant squared, I guess alpha equals tangent squared alpha plus 1.
So, may I ask a question real quick?
Yeah.
So, because I had found cosine before that, are you still able to do sine squared plus cosine?
Yeah, so you already have your cosine?
Yeah.
Yeah, once you have your cosine, you can do cosine squared plus sine squared equals 1.
Just like limited
You aren't limited to that.
to, okay.
Nope.
I just did something weird.
And in fact, Mary, you could have did 1 plus cotangent squared x equals cosecant squared x in this step too, because you do know the cotangent value. So you are just looking at this sheet and saying what values you know. Currently, I know the tangent value, and I know the cotangent value, so I could plug those values in for either one of those equations, right? Because we know cotangent and we know tangent. Whatever is probably easier to plug in.
Okay. I just did some weird math.
Oh, okay. Are you okay then?
Yeah.
Okay. All right. All right. Then today's lesson, we're just going to expand upon some simplifying expressions. Now, we're going to get to really difficult ones where these aren't always going to work. All right. These are just tips and tricks to try to see if this works by simplifying. Because tomorrow, we're actually going to prove two sides are congruent by simplifying both sides kind of at the same time. So one of the tricks we can use to simplify expressions is to, if I have two separate things with a plus or minus between them, you may want to attempt to push them together, to actually do that addition. But in order to do that addition, you need to have a common denominator. You need to have a common denominator. So let's just do, we don't need to put that in there. I'm just going to show you kind of what we're attempting here. So say I had 3 over 4 plus 4 over 5. A way to have a common denominator would be to multiply this fraction by 5 and multiply this fraction by 4. Because then we'd have 4 times 5 is 20, 5 times 4 is 20. So one of the tricks to coming up with a common denominator is to multiply each fraction by the other denominator. Right, Mike? Yep. So that's exactly what we're going to do. We're going to take this denominator and multiply this by the top and bottom. And then we're going to take this denominator and multiply this top and bottom by that denominator. So that's going to look just like this. We're going to take our first fraction, that's 1 over 1 plus sine theta. and we're going to multiply the top and bottom by the other denominator. So we're going to multiply by 1 minus sine theta over 1 minus sine theta. And I'll put in this fraction form because this is just multiplying by 1. You can do that. This is just 1. You're allowed to do that. All right, then we're going to take the other fraction that we were given. We're given 1 over 1 minus sine theta. And we're going to multiply this one by the other denominator. So we're going to multiply this one top and bottom by 1 plus sine theta over 1 plus sine theta. So once again, I just take the other denominator and multiply it top and bottom by that fraction. Then I take the other denominator and multiply top and bottom by that fraction because the whole goal is to have a common denominator. If we look at both our common denominators, they're now going to be 1 minus sine theta times 1 plus sine theta, which if you look at it, that's a difference of squares. That's a difference of squares. I'm going to put a little note over here. Note, if you ever have a minus b times a plus b, that just equals a squared minus b squared. That's difference of squares. All right, let's simplify this. So we take this and multiply it by 1. When you're multiplying fractions, just a quick rehash, when you multiply fractions, you multiply straight across. So you're going to do 1 times 1 minus sine theta. So our top is just going to become 1 minus sine theta here. All over 1 plus sine times 1 minus sine theta is going to become 1 squared, which is just 1, minus sine squared theta. Plus, we have 1 times 1 plus sine theta, so we'll have 1 plus sine theta on top. And on bottom, once again, I have a minus b times a plus b, so it's just a squared minus b squared. So that's 1 squared minus sine squared, so that's just 1 minus sine squared theta. Hey guys, do me a favor. If you make a mistake up here and you don't have a common denominator, don't try to push them together. Try to find your mistake, because you're going to lose more points if you just make up math. So I've seen lots of times where people did this and they came up with different denominators and they still pushed it together. Has to have a common denominator. All right, simplifying this, we do now have a common denominator. We have that 1 minus sine squared on bottom, so we can push them together. So we are going to have 1 minus sine theta plus 1 plus sine theta all over 1 minus sine squared theta. Well, on the top I have negative sine and a plus sign. Negative sine theta plus sine theta is just going to equal 0. And so we'll just have 2 on top. So that's just going to equal 2 on top. And see how we have that 1 minus sine squared theta? You should immediately, I'm going to put a little note off to the side over here, say that we have sine squared plus cosine squared equals 1. Because I do have sine squared and a 1 there. All right, I'm going to try to replicate this. So I'm going to have a negative sign and a positive 1. So I'm just going to subtract sine from both sides. Minus sine squared, which is just going to equal cosine squared equals 1 minus sine squared. Well, that's what I have. I have 1 minus sine squared, so that's just going to equal cosine squared. So we have 2 over cosine squared theta. Well, whenever you have cosine in the denominator, you're going to think secant. Maybe I'll do one more step here. We actually have 2 times 1 over cosine squared theta, which is going to equal 2 times secant squared theta. Something important happened here. When I multiplied these bottom denominators by 1 plus sine theta and 1 minus sine theta, I ended up having sine squared, which allowed me to change it to cosine squared to simplify it further. And that's the trick we're going to use in that next step right down below. Not that one. This one. Rewrite cosine squared over 1 minus sine y so that it's not in fraction form. To do this, we must multiply by the conjugate. So another tip to simplifying things. If you have 1 minus or 1 plus sine or cosine in the denominator, not squared, this is a trick you can do to simplify. And that is multiplying by the conjugate. So once again, the tip to doing this is the fact that I have 1 minus sine y in the denominator. 1 minus sine y, 1 minus cosine, 1 plus sine, 1 plus sine are tips in the denominator that you're going to do this trick. So we're going to multiply by something called the conjugate. All the conjugate is, whatever sign is here, we're going to switch it. All right, so the conjugate of 1 minus sine y is 1 plus sine y. So we are going to take our original fraction, which is cosine squared y, over 1 minus sine y, and we are going to multiply by the conjugate, which is 1 plus sine y. So we'll multiply the top and bottom by 1 plus sine y. I am not going to distribute that cosine squared. We're just going to leave that for a second. So we're going to have our top is going to be cosine squared y times 1 plus sine y all over, and our denominator is going to be a difference of squares. A minus b times a plus b. So it's just a squared, which is 1 squared, minus b squared, which is sine squared y. Whenever you see sine squared or cosine squared, you should think sine squared plus cosine squared equals 1. If you look right above, we did this problem already. We have cosine squared equals 1 minus sine squared. So that denominator actually just equals cosine squared. So that's just going to be cosine squared y, 1 plus sine y, all over cosine squared y. 1 minus sine squared equals cosine squared, so we can rewrite that. Cosine and cosine squared both cancel each other out, and you're left with just 1 out there, because cosine squared over cosine squared is 1. And so we are just left with 1 plus sine of y. It's not 1 plus sine squared, so you have to be done. Our next one is cosecant to the 4th minus cotangent to the 4th as well. Now, before you start turning this into sine and cosine, you're going to be careful to read the directions, because the directions will simply say simplify. It doesn't say turn it into sine and cosine and then simplify. It just says simplify. So we are just going to leave it in cosecant and cotangent as far as we can and see if we're going to need sine and cosine later on. So before we start, I'm going to once again, so you guys don't forget this, remember that a squared minus b squared equals a minus b times a plus b. Well, that's important because I'm going to expand upon that. I'm going to expand that to a to the 4th minus b to the 4th. Well, a to the 4th minus b to the 4th can be rewritten as a squared squared minus b squared squared. which means this is taking the place of this a value. This b squared is taking the place of this b value. So you can plug this in place of both of the a's, and you can plug this b in place of both of those b's. So once again, if this is a, b, and this is a, b, we're going to do the same thing with a squared and b squared. We can rewrite this as a squared minus b squared times a squared plus b squared. So a to the fourth minus b to the fourth can always be written as a squared minus b squared times a squared plus b squared. You need to be able to recognize that. Because what that means is we can now rewrite this as, instead of cosecant to the fourth, we're going to rewrite it as cosecant squared x minus cotangent squared x times cosecant squared x plus cotangent squared x. Anytime I see something squared, sine, tangent, cotangent, cosine, cosecant, anything squared, I'm going to immediately think, maybe this deals with my Pythagorean triples. So we look at our Pythagorean triples. We look at our Pythagorean triples and we find one that has both of those values in it. And so we're looking for cosecant and we're looking for cotangent. So our cosecant and our cotangent one is right here. It's 1 plus cotangent squared equals cosecant squared. So we have 1 plus cotangent squared equals cosecant squared. Well, I need to get the cotangent and the cosecant on the same side, so I'm going to rewrite this as 1 equals cosecant squared x minus cotangent squared x. Well, that's right here. Cosecant squared minus cotangent squared equals 1. So this just equals 1. So that whole thing just equals 1. And that's actually how far we can go. That is fully simplified. If you change it into sine and cosine, you're not going to be able to go any further than that. You're actually going to complicate stuff because you won't be able to push it together. All right, questions on that? Okay. We're just going to do one more, where I have sine cubed over sine cubed minus sine x. We can't do anything with cubes. If you look at your Pythagorean triples, that's the highest power you can get to, and that is squared. So we need to get down to sine squared instead of having sine cubed. A way to lower a power is to factor out a power. Factor out a power. So we are going to factor out, and we're going to look at the denominator. Notice the denominator has sine cubed minus sine x. We're going to factor out a sine of x. Which is going to give us sine cubed x on top, all over sine of x times sine squared x minus 1. Well, now I have sine cubed x over sine of x. Now, either you remember stuff about powers, where this would cancel out, and you'd just be left with 2 here, or if you don't remember that, you can go the long route and say that this is sine of x times sine squared x all over sine of x times sine squared x minus 1, and your sines cancel out. I'd much prefer you to know the power rules, that when you are dividing stuff, so this is kind of the long route. This is the route I'd prefer you to know how to do, where this sine x, and this is going to turn to a 2. So we are just going to have sine squared x all over sine squared x minus 1. Now we have sine squares. That is our Pythagorean identity, has all of our sine squareds in it. So once again, you should be thinking sine squared plus cosine squared equals 1. This time the 1 is negative and the sine is positive, so I need to move this 1 to that side and move the cosine to the other side. Maybe I'll do all the steps. So we could rewrite this as sine squared plus cosine squared minus 1 equals 0. Subtract both sides by cosine, we'll have sine squared minus 1 equals negative cosine squared. That matches that, so we're going to replace that with negative cosine squared. Now, sine over cosine is either going to be tangent or cotangent. Does anyone remember which one that would be? Mary? It would be tangent. And since it's squared, it's just going to be negative tangent squared x. All right, real quick rehash. If you have anything cubed, you need to get down to squared. Usually factoring will be the key to getting it squared so that you can use the Pythagorean identities. If you have things to the fourth, you need to get it down squared. Use your difference of squares property with fourth powers to get it down squared. If you ever have 1 minus sine y, 1 plus sine y, we'll see plenty of those coming up. Multiply the top and bottom by its conjugate. And finally, if you have two fractions that are separated, you can push them together by creating a common denominator. All right, questions on anything we covered today? It was actually a ton of stuff, and it's going to get more and more challenging before it gets easier. Yay. But if you understand what we did today, it makes your life a lot easier. If you're just like, I don't know what just happened, now's the time to ask questions. All right, and the rest of the time is yours to work.